Hello, today I want to show you what the book really looked like. This is our book, and it was published by the Noether, and this is a very nice publisher, and we love working with them, and it's also give a lot of help. So let's get in what this book actually really looked like. So let me focus slightly so you can see a little clearly. So the first floor, this book in total has 390 pages, and it started with the preface, and also have some guidelines how to use this particular book. So this is a summary, and a few things that is very unique to our book is the following. It's we have a table like this in the beginning, and so it listed for each of these chapters we have key concepts, and this includes formulas and experiments. And the last column is the semesters. If you just have one semester class, for instance, the chapter number 2, we will recommend you just cover the first 6 sections. So, and so on and so forth. All these formulas are very useful because we found many books, they always put a formula in the back of each chapter, which is of course convenient, but in our opinion, if they are really important, you should really put in the cover like this, what we have doing here. So, and for instance, the chapter 10, we have quantum computing. You can see these gates are listed there, and entanglement. So that's just a quick overview of what this book is all about. Let's flip around. This is the table of contents, and so we start from the chapter number 1. And then move on chapter number 2, essentially on the bound and unbounded states. Then chapter number 3, oscillators, and keep on going until chapter number 4. I hope you can see that is on the hydrogen atom. So we after the hydrogen atom, and we essentially decided we want to have time-independent approximate methods. This includes the perturbation methods and the variational method, which is on the next page, which I'm going to show you. The main reason why for the one semester class, if we only stay with our very limited methods, and this allows students at least see the hydrogen H2 plus molecules, so they will be able to experience the molecule orbitals. Then chapter 6 started with the electron spins. So that's electron spins. And some experiments, which I'm going to flip around and let you to know. After the chapter number 6, we move on to time-dependent perturbation theory. In particular, we will apply to the optics. And we found out this is the real attractive for our students. And what is unique in our book? We have the linear optics, which is the bullet itself, and we also discuss the laser as well. The laser is quantum mechanical, and chapter 8 essentially is cover the molecules, electrons in the molecules, and one-dimensional solids. Now, if you have a 1-year course, we would encourage you to cover at least chapter 8, 9, and all the way to 10, like that. So I'm not going to go too much detail. I already passed 3 minutes. So let me flip around. So for instance, for the chapter number 1, we're entering the quantum world. At the end of this particular, almost close to the end of this particular chapter, we have the measurement discussions. One thing which is also very nice, which we have special way to present. Let me just back up a little slightly. On the probability density, which is quite important, difficult concept. What we did was we introduced a airplane here, to explain the probability density. Probably in another video, I'm going to show you how we actually use this. Now, the last part of this particular chapter is a measurement of the Planck constant with the used LED. Oh, students love this one. It's really exciting. So these are actually student data in our advanced laboratory course, and we have student data, and you can measure the Planck constant. Since this book is quite thick in some sense, but it covers quite a lot of materials. let me jump ahead slightly. So for instance, we are in the chapter number 5, and we also have the very detailed derivation of the angular momentum operator. So these are the angular momentum operator. What is unique to our book is that we have the hydrogen code. So let me show you the hydrogen code. So here's a hydrogen code. So all the way up to here, you can see discretization. And when we teach this course, and I found students love this part so much because they can calculate any orbitals we want. Let me show you what I mean by this. You see, you can calculate from 1s, 3s, all the way up to 5ds. You could have f orbitals. And this particular part is actually, we have a code in the back of our book. So that's the hydrogen code, which is over here. So let me show you a little bit more detail. So this has, we have, so here's a hydrogen wave function, as you can see here. And this is calculated with that particular code. And then for the perturbation theory part, we also discussed the van der Waals force, and then this is the degenerate perturbation theory. This is quite useful because now we can understand the H2 plus molecules. We also can plot the H2 molecule as well, so which I'm going to show you in a second. So this is variational principle methods, and here this part is the functional derivatives. And many books, they do not cover this part, so we cover this. It's a really nice way to introduce them to the density function theory. So you see density functional is here. So once we have variational principles, we can calculate the these are all calculated this way. You see, plot orbitals and get the total energy plotted. So this was extremely useful. Here's the total energy plot over here. So exchange part and column part, and you can directly do the calculation. For the electron spins, we are very proud that many of these experiments we do it ourselves. For instance, this is the Zeeman effect. So we do the Zeeman effect. You can see linearly polarized, circular polarized light. This is linearly polarized, but it's circular. And this is the Navis gene in other books. We also did the ESR experiment. That's experiment data and the theory. Let me show you our setup. So we have a setup over here. So this is our setup. You can see this ESR measurement. We have a harmonic coil, and inside of this there is the megahertz of the wave generator. We also have the MRI discussed. Okay, let me I'll go a little quickly because I don't want to run too long. And then chapter 8 is on the molecules. And also one thing that we did was we include the Cornish-Penny model, which is over here. We show all the details derived. In many cases, many books stops here, including Kittel's book is also stopped here. We show you how this equation actually derived. So these are all detailed steps. It took about 3 days to finish all derivations, but we got it really accurately. So then we can plot band structures. Students love this part very well. So we tested in many cases, many years, and we found this is really elegant. Now finally, this is the solid state physics. We provide detailed derivation of the block theorem. And in many books, they do not cover solid state theory because nowadays solid state is so important. What is also included, of course, the tidal body model and the nearly free electron model. We also include, believe it or not, the position operator. So here's position operator, which is over here. And we can calculate, you can see this is the Berry connection. So this smoothly transition to the next chapter, which is very nice. So we also include the Landauer theory, and you'll be surprised if you ask a physicist. Most of the time they don't know what they actually Landauer theory. And so you can see the experiment. This quantized the conductance. This is measured in room temperature, not in a lower temperature, the room temperature. So and this is from the experiment done by a group from I think England. So this is a really nice experiment, and then we can calculate conductance. You see here the conductance, and IV curve. This is on the nanometer scale. IV curve. I never seen anyone actually did this. And then for the latter part, we also discuss the phono vibrations. We also did the phono modes like these. The last chapter is on the many-body cases, and for those of you interested in quantum computing, which is over here, exchange interaction, which is also here, and Heisenberg model. This is my favorite, because my part of research is on the magnetism and interaction with the laser. So that's why I'm kind of very familiar with this part. And quantum information technology, which is illustrated over here. So, and you have to see the quantum bits. And we also designed a few additional the exercises. I hope you guys can see that. So these are the, let me focus a little bit further. Yeah. So this is the some exercises. And of course, we also include the periphase. Yes, very famous periphase. All the derivations. So one thing that's nice is in each section, after each section, we always have short exercises. So we encourage you, you need to finish these exercises every time, each sections. And in the end, we have a longer problems. You can see here the longer problems. You can cover them a little more comprehensive. And so let me show you the codes once again. These are codes which we, many of these is actually use them to find the results to do the calculation. All right, so I think I need to stop here. I don't want to run too much.